Yeah, hello everyone. So in this video, I'm going to explain you regarding metals, non-metals, and metalloids all together, their general behavior as you are able to see on the screen here. So it's nothing but the general behavior what we am discussing here. Later on, how the in the periodic table how they vary, what is the way where they are going to represent, right? How the variation goes on. That is also the point what I'm going to discuss in this video here. All right, if you check it out, so the general behavior what we are discussing here, all right, of course, all the elements, all the elements which are nothing but the total 108 in what we are talking about, they has been classified as metals, non-metals, and metalloids. Okay, it's clear cut, right? The total metals elements are classified as metals, non-metals, and metalloids. And what are these metals? All right, of course, we are talking about the general property. They are good conductor of heat and electricity. They conduct all elements, whatever. You taken an example of copper, right? As you all know, it conducts electricity, which we use in the household, right? In the same way, if when electricity is being conducted, it becomes too red and hot, right? It gets heated. Means what does it mean, right? The example what I had given, copper, it conducts heat and electricity. This is the point what you have to remember. And these metals generally, they are malleable. What is the meaning of malleability? They change their shape when needed, right? When made to change their shape when made to change. They can bend, whatever it might be. So the next one is they are having ductile nature. What is the meaning of ductile nature? They expand when a force is applied or when pressure is applied. Okay, so these are the properties of metals. The metals, so the first property, what I said, is nothing but they conduct heat and electricity. Right, they stretch them, so they change their shape when force is applied, or they extend or they expand when force is applied. Okay, these are the properties of metals. Of course, very, very important. What is the state in which they are? Are they in solid state or a liquid state? If you think about that one, they are in solid state at room temperature. All our metals, they are in solid state when they are in a room's temperature. Now, how do they look like? What is the physical look? They are silvery, shiny. They shine. All the metals, if you see, like you take the copper example or the gold example or silver, they shine. So that's what all the metals, right? They shine. Now, if you come across the non-metals, all right, I'm talking about the general behavior. I'm not talking about how they vary in the periods and all. Right, I'm talking about non-metals. They are poor conductors of heat and electricity. They're exactly opposite of our conductors. Whereas metals, I said, they conduct electricity, whereas our non-metals, they don't conduct heat and electricity. And of course, they are not malleable or they are not ductile. Means they won't change their shape or they won't expand when force is applied. Right. So what is the state in which they are? That's what all the metals, they are in gaseous state at room temperature. Generally, whereas metals, they are solids at room temperature, whereas these guys, non-metals, they are in a gaseous state at room temperature. This is an important difference what we have to understand. Now coming to our favorite, it's nothing but metalloids. Metalloids are also called as semiconductors. You have to remember that one. Right. How these properties, what are the properties? Are they matching to the metals or are they matching to the non-metals? That is the point what we have to discuss here. It's clearly cut. These properties, the properties of the metalloids, but the properties of the metalloids are the intermediates. We are talking about the intermediates of their, right, in the physical features, they look like, they look like non-metals. Right, and in few circumstances they look like they are like okay, so they in few cases they look like metals. Means the properties of the metalloids are the intermediates of the properties of both metals and semi-metals or non-metals. If you discussed about metals and non-metals, these guys are having the properties of intermediates between the properties of metals and non-metals, are intermediate in their property. In their physical papers, they are more like non-metals, but under circumstances, several of them can be made conduct electricity, means they can be made. Right. So you have to remember these semi-metals, which are very, very important in making many instruments in the computers or many other electronic devices. So these are the different, right, a few general behaviors of metals, non-metals, and metal. Yeah, till now we have been discussing how metals, non-metals, and metalloids, they vary and in their properties in general behavior. Now, in this topic, I'm going to discuss how they vary in the periodic table. In the periodic table, in the modern periodic table proposed by Mr. Moseley, how the metals, non-metals, and metalloids vary. All right, what are their properties? Let us see. Now, if you see here, the first point what I'm saying is the elements with 3 or less than less electrons in the outermost shell are considered as metals. So this is the first point. You know, right? Nucleus is at the center, first orbit, and the second orbit, and the third orbit, or whatever might be the orbits. If we are having 1 electron in the outermost, this is the outermost orbit, right? The outermost orbit. All right. If it is having only 1 electron, then we call it as 1 electron, right? We call it as in the outermost, right? We call it as metal. We call it as metal. In the same way, if it has 2 electrons also, 2 electrons in the outermost also, we call it as metal. In the same way, if we have 3 electrons also in the outermost orbit, right, in the outermost, then also we are calling it as metals. That's what the point says. The elements with the 3 or less electrons in outermost shell are considered to be metals. Instead of calling outermost shell, I can directly say valence electrons, right? Valence electrons. If the valence electrons are 3 or less than 3, we call them as metals according to the periodic table. Now let us take an example of sodium, what it is given there. All right, here if you see the electronic configuration 1s2, right, 2s2, 2p6, and 3s1. If you check it out, the outermost orbit, this is K, this is L, and this is K, L, and M. M is the outermost orbit, and it is clearly saying the outermost valence electron configuration is 3s1. What does it mean? It has 1 electron in outermost. All right. So as it is having only 1 electron in the outermost, I can take sodium as a metal. Sodium as metal. Why? Because it says valence electrons 3 or less than 3. That is what the point says. Okay. Now, if you come to the second point, there is a staircase like a demarcation in the periodic table. You can check it out. The yellow colored one, if you check it out here, right, it's nothing but, this is nothing but the staircase in the periodic table. It's looking like a staircase, right? Right, all those things, it's looking like a staircase. That a staircase like a demarcation can be noticed. Now all the elements towards the left side, of the demarcation can be considered as metals according to the periodic table. Right. So staircase is there. Whichever are the elements which are towards the left side, we are calling it as metals. Now, so I said you, according to the valence electrons, valence electron 3 or less than 3, then we call it as metals. That is the case 1. That is condition 1. Condition 1 and condition 2, what we said means left side of staircase, left side of staircase. This is the second condition what I am saying. Now, after these two conditions, which block elements, as we all know, we are having S block, we are having P block, we are having D block, we are having a F block, right? Out of these, which are nothing but metals, which block elements belongs, comes under these metals? Let us see. The first condition, what he says, if you check it out, this S block element, this is nothing but S, and this is nothing but D, this is nothing but F, and as you all know, this comes under P block elements, right? This comes under P block elements. Here clearly saying S block, if you check it out, where is the location of S block elements? S block elements are towards the left side, right? S block elements are towards the left side. Here the S block elements are there. Here they are. So according to the condition 1 and condition 2, S block elements which are towards the left side of the periodic table, left side of staircase, you can take like that. Left side of staircase, you can take like that, or their valence electron, you have to consider S block elements, valence electrons are 1 for group 1. Yes, in the same way, valence electrons are 2 for group 2. Right, this is nothing but the group 1 and this is nothing but the group 2, right? By following both the conditions, we can say S block elements are metals. You have to remember. In the same way, if you come to the D block elements, if you think about the D block element, these are nothing but the D block elements. D block elements satisfy both the conditions. Condition 1, what we said, valence electrons are equal or less than 3. That is also satisfied by the D block elements. In the same way, condition 2, what is the condition? Left side of the staircase, left of staircase. Right. So both the conditions are satisfied by the D block elements. Therefore, D block elements are also metals. That is the point what we have to remember. Now, but if you check it out, D block elements are not staying at one place. They are moving from left to right in a periodic table. They are moving from left to right. This is the left side of the periodic table, and this is the right side of the periodic table. These D block elements are moving from left to right. So as we move from left to right in a periodic table, the metallic character of D block elements keep on decreasing. D block elements metallic property decreases as we move from left to right. Why? Because here the valence electrons are nothing but it is 1 or 2 or 3. Whereas when we go towards the right side, the number of valence electrons are increasing. Increasing means it is no more satisfying condition 1. That's what we have to remember. As we move from left to right of a periodic table, metallic character decreases of the which block? D block elements. Now, if you consider about the F block elements, of course, left block elements, we all know the first 14 are nothing but the lanthanides. Okay, and the second 14 are nothing but the actinides. Okay, but you should know both the F block element, they all belongs to the group 3. Yes, 3A elements they are, right? And the 3A elements are having valence electrons as a 3. Right. So according to the condition 1, if the valence electrons are 3 or less than 3, they become metals. Therefore, all F block elements are nothing but metals for us. So this is the point what we have to remember. So all the F block elements comes under metals for us. So if you think about the non-metals, right, if you think about the non-metals, it's clearly instructed for us. So here both the conditions vary, right? Here the condition is if the valence electrons are greater or equal to 5. This is the first conditions. And the condition 2, right side of staircase, right of staircase. These are the two conditions you have to remember. right? So the elements with, here it is clearly giving the elements with 5 or more than 5 electrons in the outermost shell are considered as non-metals. And the second condition is they are towards the right side of the demarcation, which is nothing but the staircase. These are considered to be as non-metals. Here, if you want, we are giving the example of fluorine, atomic number 9. And if you check it out, valence electrons are nothing but the 7, which are greater than or 5. So which is nothing but the second condition. So these are nothing but the non-metals according to the modern periodic table. Now, our favorite one, which are nothing but the metalloids. General behavior, we thought, we are discussing about metalloids. Metalloids, which are nothing but the semi-metals. Now, where they are they following condition 1? Right, or they are following condition 2. How many conditions they are? What are their valence electrons? That's the confusion. So here, valence electrons are close to the 4. You have to remember. And condition 2, it is on the staircase. Right, if you remember, right, they are on the staircase or very close to the staircase. You have to remember, we are having 3 conditions. That is, valence electrons are close to 4, and they are on the staircase, and they are very close to the staircase. These comes under metalloids. If you check it out, metalloids are semi-metals, are metals which have the properties of intermediates between the properties of metals and non-metals. Where they are placed, they are on the staircase, on the demarcation, nothing but the metalloids. And if you check it out, which comes under metalloids or semi-metals, the important one are silicon and germanium. Right, of course, boron comes under also semi-metals, and the AS also comes under semi-metals. But the very important are silicon and germanium. So as condition it is given, right? So all the elements which are very close to the, right, these elements are also considered as non-metals, right? Of course, so these are very, very important. Of course, here they are having the properties of both metals and non-metals. Now, coming to the last group, which is not last group, we are talking about a P block element as an important note I am seeing here, right? The P block element consists of metals, metalloids, right, and also non-metals. This is the important point what we have to consider. So we are dealing with conditions. Right, as a recapitulation, I like to recapitulate. If you check it out, for metals, we are having 2 conditions. For metals, we are having 2 conditions. Condition 1, right? What is the condition? Condition 1 regarding the valence electrons, 3 or less than 3. And condition 2, left side of staircase, right? Left side of demarcation. That is right. Now, non-metals, we are going again with 2 conditions. What they are? Valence electron greater than or equal to 5, and they are towards the right side of the staircase. That is so and so. And what about the metalloid? They are going with 3 conditions. They are on the staircase, valence electrons close to 4, and the elements which are close to the staircase are also considered as metalloid. So hope you are able to understand the difference between metals, non-metals, and metalloids, both general behavior and according to the modern periodic table.